In this video, I want to discuss the part C, the oxidation of alcohols in lab 23. So this was discussed at the tail end of chapter 12. And so just like for the rest of this lab, it's recommend that you watch the lecture videos for chapter 12 before doing the lab. And what we saw here, and I'm not going to go through specific ones here, I'm just going to give you a summary of what we saw with the reactivity of alcohols in an oxidation reaction. And then I'll discuss more specifics about this reaction. One thing we saw was that primary alcohols will react under oxidizing conditions. And remember, all we did there is we did an O in brackets to indicate that oxidation was occurring, and it produces an aldehyde. There can be a additional reaction to a carboxylic acid. So for example, in this column here, for the primary alcohols that you see here, you can write either the aldehyde or the carboxylic acid here. If you want to write both of the products, that's fine as well, but just write one of them for the oxidation product. Secondary alcohols, these are the ones, they just go one step to a ketone. And then just to sort of finish out a thought about chapter 12 in general, what we talked about, oxidation of ketones, there's no reaction for ketones under oxidizing conditions. And then the last one is our tertiary alcohols, and these, there's no reaction. Now, the way that we are determining whether a reaction has occurred or not, it's a color change. Okay, so the oxidizer in this solution it's basically a chromic acid solution. Okay, and it's produced by mixing sulfuric acid and I think potassium chromate or dichromate. Either reagent would work here. This is a qualitative analysis type reaction, so it's a kind of, if a color change occurs, then yes, it's undergone oxidation. That's your typical like qualitative analysis, and that's all the reactions in these organic labs pretty much. So we're using a color change to determine whether oxidation has occurred or not. And the color change we see here is this. So the chromic acid solution is fairly dilute. It's sort of a yellow-orange, I'm going to say orange color. And if oxidation has occurred, then it goes to greenish. It just depends on, how much of the original chromate is left, just how green it is. So if you see this color change in the video, and it's a really short video, you'll see all of these are very short videos for this lab, then it's a yes or no, right? If the color change has occurred, yes, oxidation has occurred, and then you go through all these questions here. And the last thing, if it stays orange, then there's no reaction. Let me talk about a specific one, the phenol here. You can record the information here, but in some ways we're just going to skip that one. I think what's happening with the phenol, it's like decomposing. That's what it looks like to me, because it turns sort of a dark brown, almost black solution. And I have seen a black solution phenol. I don't think the video quite goes black. And usually when I see, that kind of dark black kind of solution, I associate that with decomposition. Long story short, the phenol group, those aromatic compounds just act differently. So the hydroxy group on the aromatic ring actually causes that ring structure to be really reactive under certain conditions. And I think that's what's happening here. And actually, I am going to just mark that out.